heard them before. Harry Enke is section head of the group Supercomputing and E-Science at Leibniz Institute für Astrophysik Potsdam, AIP. And in NFDI, Harry Enke is leading the PUNCH4NFDI's task area for the data portal. Also, Harry has been for quite a long time, I think as early as 2010, at least been active promoter of research data management. Kilian Schwarz leads the group Distributed Computing of the IT department of GSI Helmholtz Zentrum für Schwerionenforschung. In NFDI, Kilian Schwarz represents GSI as a co-applicant in the PUNCH4NFDI consortium. The topic of their presentation is PUNCH4NFDI Collaborative Tools for Effective Information Exchange and Interplay with AAI. Harry, Kilian, we are looking forward to your talk. The floor is yours.
Thank you, Kurt. And I think I will begin since you already stated what PUNCH4NFDI stands for. I will just go on and say that the collaborative tools we want to introduce today are part of our development, which has two key elements which are named in the starting slide. That is our science data portal idea and the digital research product. And we'll, among other things, will try to explain why this is the case. So let's just brief. You might already know that we comprise a substantial part of not only our communities in universities and extra university research institutes and infrastructure institutes where a lot of that is located. So this is a kind of depiction of what we all have as partners within NFDI. And of course, some of them are represented in many of the NFDI consortia as well. So two things. Our science data platform idea and is more or less the central element or hub, and will be also the external access point for the PUNCH and broader communities. For services, we want to run on the hardware which is already owned by the community, used by the communities which we are representing, and we want to integrate these into a execution environment. And for that, we need also a kind of compound from data, software, workflows, workflow engines, and batch systems, and all kinds of services which work together. And this digital research product is, as an idea, one of the crucial things. I will go into that a little bit later. So this is a rough sketch of our setup. So this is task area 4 with the portal, and you see already AAI there plays a big role. And we have all the various sources where we need meta descriptions, workflows for these. Then we have all kinds of different elements. We have then computing and storage elements we need to integrate in existing workflows or creating new ones. And all this is kind of a problem we work together, and but different task areas, as in every other collaboration is approached. So the digital research product is was formed during the discussions which led to our proposal, where we had to notice that the different elements of data are not sufficient for our endeavor. So not only naming data or collecting the data storage in some metadata systems, we need also get a grip on workflow and analysis software and on data publication policies, for instance. For the science data platform, we need a kind of seamless integration of these resources. And so one of the, what led to this is that we have to take into account, especially for our communities, that the most used data collections are not within our grip or our realm. We can't prescribe to, for example, the experiments at Alice or whatever other experiments run at CERN, and their huge data collections. We can't prescribe how they manage them. We have to live with trying to integrate them with other resources, and same goes for huge resources from astronomy. As somebody who attended our compute and storage talk last week was introduced to. So we have data production sources which go into the exabyte. And of course, they are not within, so we can't just copy them or manage them by ourselves. We have to rely on convincing the community to adhere to some standards and to some requirements we will use to form to make this data product something which can be executed and access to the diverse resources and so on. So that's the idea of that. It's way more complicated than just writing it down, but we are convinced, since we already have a lot of different elements at our fingertips, and that is digital elements and not just kind of libraries where rows and rows of information in books, but we are talking about digital products, and we have there a lot already which can be used to start from there and not try to reinvent or re-prescribe everything again. So these are the elements of the research product, and the registry and the store will be part of the science data platform. So yeah, I just made here a kind of attempt to have a to make a list of things we already have for use and inclusion into the digital research product. And our approach, I think, will relieve a little bit the problem, for instance, that we know, for instance, from high energy physics, that a lot of metadata is not explicit in some kind of metadata system like kernel 4.3 of DOI or something, but built into the software. And we don't estimate that we are able to extract and make this all kind of explicit, but we need to accommodate these kind of situation. And that is one of the important things for the digital research product. You see always the portal and the AAI crops up wherever we talk about. And with this, I pass now to Kilian to explain a little bit more about the AAI and what we already have set up or can use.
Okay, before I start with the AAI, I just want to start with a little disclaimer. I actually sent you yesterday an updated CV. I also work now as a head of scientific computing at DESI IT. Okay, coming back to AAI, here we have the RARC blueprint architecture. The first European Union RARC project was running from 2015 to 2017. And RARC stands actually for Authentication and Authorization for Research and Collaboration. It provides a set of building blocks which can be used to implement federated access management solutions. So here on top, you can see the building blocks for user identity, which are actually services which provide electronic identities. Then you have here on the left side, the community attribute services, which are components related to managing and providing information, which is attributes about users. Then in the center, you have the access protocol translations, which is working as a boundary between internal and external services and resources. Here on the right side, you have the authorization components, which are elements to control how users can access services and resources. And down here at the bottom, you in the end have the services, which shows where the external services actually interact with the elements of the AAI. The complete RARC blueprint architecture document you can find in Zenodo under the link which is given here on the lower right side. So next slide. So B2Access is providing actually a federated authorization and authentication proxy for user identification and community-defined access control. It allows using a variety of credentials, providing federated access and single sign-on. It is an RARC compliant AAI proxy ready to be integrated within the European Open Science Cloud AAI Federation. So here on the left side, you can see identity providers providing here identities like in the form of X509 certificates or social identities. Also here OpenID, for example, identity providers from research infrastructures. Here in the center, we have the B2Access AAI functions, which is a multi-protocol identity management solution powered by Unity identity management system. Unity is actually a complete solution for identity and federation management. It is provided on a public source code repository on GitHub. And then here on the right side, you can actually have, you have here the service endpoints, which can be accessed, for example, via access tokens or via X509 certificates. More about B2Access you can find here on this link on the lower right side. So now I come to the Helmholtz AAI, which I want to talk a bit more in detail. Helmholtz Authentication and Authorization Identity is maintained by the HIFIS Helmholtz Federated IT Services. The central component of the Helmholtz AAI is a Unity instance. What Unity is, I just mentioned, that serves as a proxy. What a proxy is, I will also talk about a bit later, between your home identity provider and the service you actually want to access. So here, as an example, you have several services. For example, service A offers multiple authentication mechanisms. For example, here it can go via DFN AAI, but also via Helmholtz AAI. Service B is only connected to Helmholtz AAI, and service C is connected via infrastructure proxy. The Helmholtz AAI in principle offers here identity management and also group management infrastructure. How we design our group infrastructure, I will come later in the next slides to that topic. And then in the end, a user who wants to authenticate via Helmholtz AAI, in the end has to be identified by identity providers, which can be in principle a center in the DFN AAI, because Helmholtz AAI and DFN AAI work in a federation. You can be identified by a center in the Helmholtz AAI itself. Also, you can be identified via social identity providers, for example, using ORCID. Okay, next slide. So the basic concepts of the Helmholtz AAI is it is organized in virtual organizations and is based on the proxy concepts of the RARC blueprint, which is what I mentioned at the very beginning. So the Helmholtz AAI policies, they are also in line with the AARC policy development kit. So the first component, the virtual organization, is in principle a number of users. So each virtual organization consists of a number of users. The virtual organization should also be supported by a number of services, and a virtual organization is managed by a virtual organization administrator. Then the second central concept is the service provider, identity provider proxy concept. So if you have in an AI setup a growing number, or in a federated identity setup, a growing number of service providers and also identity providers, it becomes increasingly difficult to maintain a consistent attribute release and manage that. So the proxy is actually reducing the N-to-M mapping from service providers to identity providers to an N-to-1-to-M mapping, which simplifies this infrastructure. Some authorization attributes, moreover, as for example, group memberships, cannot be reasonably maintained at home institute identity providers. Moreover, the proxy allows translations between different AI protocols. So this means, in the end, for a given community, there is one central software stack implementing the service provider, identity provider proxy for the community, which is the community AAI. And in the Helmholtz AAI, the central software stack is based on Unity and is operated by Forschungszentrum Jülich. The services and the infrastructure proxies, they can then be operated at various sites. So the PUNCH AAI is basically providing the PUNCH4NFDI as a virtual organization in the Helmholtz AAI. And there is a hierarchy of the groups. You can see here, the group claim is actually going down from GEANT to dfn.de via nfdi.de and finally to the PUNCH group. So the PUNCH AAI is thus an endpoint of the Helmholtz AAI. Next slide, please. So here, this is a bit more in detail, the concept of the virtual organization and the groups. So the information provided from the PUNCH AAI to local service providers for PUNCH services to be evaluated is in principle here the group structure I just mentioned. The group claims are GEANT, DFN.de, NFDI.de, PUNCH as a group in the end, and the user which authenticates to the service. Here, the user information is also provided for this specific user. The user is also in the PUNCH intra group. I come later to that. The PUNCH intra group actually allows a user in the PUNCH AAI to access local PUNCH services, which are specific for PUNCH users. For example, the intranet and other services, we come later to that. And also in this case, the user which tries to use the service is actually a group administrator also of the PUNCH4NFDI VO. Okay, next slide. So how does that actually work? So log in to PUNCH4NFDI services and tools. They should be done preferably via single sign-on, which is a user is supposed to use the PUNCH AAI. All users, therefore, need to be registered in the PUNCH AAI. So how does authentication and authorization work using the PUNCH AAI? You just go as a user to the service which you want to access and which supports the PUNCH AAI. For example, the PUNCH intranet. So here, when you go to the PUNCH intranet, you are first offered the screen, sign into intranet, and you can do that via Gitlab. How Gitlab is involved in that, Harry will talk later on that more in detail. So when I choose Gitlab, I'm actually offered, I can of course provide in principle local user ID and password, but this is not recommended. So instead, the user is supposed to sign in via PUNCH AAI. And if a user is using that, then the user is redirected to a page where the user can choose actually the home identity provider, which is usually the home institute of the user. So in my case, I'm looking now for Darmstadt, and I find the Hochschule Darmstadt, University of Applied Science, where I actually have a professorship there. So this is one of my home institutes. So here I log in then via my user ID and my passport, my password of the Hochschule Darmstadt, University of Applied Science. And then I just have to confirm that I'm happy that my data are being processed by the PUNCH AAI services. And if I confirm that and allow that, I'm in the end redirected to the intranet. So without the necessity to have a local password and user ID combination, I just logged in via AAI to a local PUNCH4NFDI service, which is our intranet. Harry will talk a bit more in detail about how this intranet is working and how it looks like. Next slide. I also mentioned that we have a group concept in the PUNCH AAI. So here's a diagram of the groups we have currently in operation or we currently thought of. The base group is basically the PUNCH virtual organization. So every user who wants to use the PUNCH AAI has to be registered in the PUNCH group, in the PUNCH base group. So if a user additionally wants to use PUNCH related or PUNCH specific services, like for example, the intranet I just mentioned, the user has to be a member also in the PUNCH intra group. Additionally, so the PUNCH intra group in principle allows access to all PUNCH or to most PUNCH internal services. Additionally to that, we provide project-related groups. For example, here, epidemiology, which is doing research about the corona pandemic situation. Compute for PUNCH is a project which actually provides a prototype of a distributed computing infrastructure for PUNCH4NFDI. So users who are registered in this group, they can actually use the resources, the compute resources provided by Compute for PUNCH and run their analysis, for example, there. LOFA and MERCAT are astronomy experiments or observatories, and they actually, these two groups are data-related groups, at least for the time being. The idea here is that we want to copy data of LOFA and MERCAT to storage for PUNCH, which is another project which provides a distributed storage prototype for PUNCH4NFDI. So the idea is here that we want to copy data from LOFA and or MERCAT to storage for PUNCH, and users registered in these groups, they can actually access, and only these users can access these data and do, for example, data analysis with these data of LOFA and or Meerkat. More groups we added recently is, for example, DIGUM. We made a joint collaboration with Erum Data, which is research for universe and matter. And here we provide now also a Gitlab repository for users from Erum Data. And these non-PUNCH users, they can access now also via the PUNCH AAI if they are registered in the project group DIGUM. More project-related groups will follow later. And for each new group we create, we require actually for the policy, the name and address of the group administrator, the reason why this group came into existence, what resources are actually required by the users of these groups, and which persons are entitled to become a member of this group, and also how long this group is supposed to exist. If it's a permanent group or if it has a time limitation which runs out at, for example, 2 years. So next slide, please. So we also have to administrate the PUNCH AAI. Here is the interface of the administrators. For the administrators, you can see here the groups are actually mentioned already. You have the base group, PUNCH, and you have also here the PUNCH intra group. You have LOFA and Meerkat. You have the DIGUM group and the epidemiology group, which I mentioned. You can have a list at the members of each groups, and you can actually send out invitations to users if you want them to become member of a certain group and of the PUNCH AAI. And if a user registers at the PUNCH AAI, the user appears here in the user updates, then the administrator has to confirm or decline the request of the user to become member of the PUNCH AAI. You can see here also that a few of these groups, for example, ALPS or DIGUM, they have been made sub-projects. And if a group is made a sub-project, you can actually assign a sub-project administrator, which is a subgroup administrator, which can then manage the users of these subgroups. Okay, next slide. Then I hand over back to Harry.
Sorry. Okay, this is just a reminder that we are always thinking in the frame of our science data platform and where we want to be. This might be something somebody knows, and this was a collaboration between different parties in the NFDI for infrastructure. This picture, I just raise it because these elements here in blue, these are all in another view of elements which need to be included in a portal for PUNCH or even other portals. And below you find a lot of different resources to use. I just will now pick an example how the portal needs to be collaborating or led by the AAI. So we have, as you might know, we have this Gitlab setup, which is important not only for storing compute things like software code. This has a lot of other uses, and we are trying to max out these other uses as well. So Gitlab also has a container registry, and you put here, you see a couple of containers. Not every project in the list is a container, but many of them. And these containers can be deployed to the hardware I showed here. So from the container registry, it can be deployed to compute resources or can be used as extracting more storage data from storage resources which are normally not available by each and every one. So I just depicted this workflow a little bit more. So our research product will contain information about that. Of course, if there is a publication based on that, this will also be included at least as pointers. But via Gitlab, if this research product contains the information, there is a container available which implements a kind of workflow or a certain piece of analysis software. It can be deployed if in a container registry. Then it can be used to deploy it to this overlay batch system, which is part of the computing resources we have available in PUNCH4NFDI. And there is a caching mechanism, so the container also could, for instance, access first storage resources and deploy them or store them in caches, because if the data is huge, you don't want to this somewhere else. This incurs a lot of latency, and you want to have it near the compute resources. So these kind of mechanisms you can wrap up in such a container, just as an example. And this will be then guided via Gitlab, which offers you also the opportunity, for instance, to change code within this container and make a new one and redo analysis for other pieces of software. But crucially, of course, you need the AAI permissions propagated. This can be done by Gitlab or by other means or stored in the container, so you can access the resources which are available, but selectively available. That's one of the very important things you have always to keep in mind, that each service is just something where you have locally an administrative domain which allows or doesn't allow people who are authenticated by AAI to access resources, because this authorization part becomes important here in this whole domain where you need to propagate also permissions. Okay, thus far, we used Gitlab for that, and I can now pass again to Kilian. So, and I hope we are not getting over time, because we have a couple of slides still. Kilian.
Okay, so you can see here that our intranet and Gitlab provides the possibility to edit and to add documents via Gitlab. This lands in the end in the repository where the arrow points to in the intradocs contained, and changes are propagated to the intranet in the end with git commit. And before actually the changes are, before the changes are committed, there is also a syntax, a pre-commit hook, pre-commit syntax, which actually prevents error propagation. Okay, now we can go to the next slide. So, and when you are finally here in the intranet, you can see this is here a view how we arranged our intranet here. We have information about the consortium. We have information about the various task areas, task area 2 to 7. Task area 1 is our management task area. Here you see that also in the circle. Task area 2, data management, data transformation, data portal, data irreversibility, synergies and services, and education, training, outreach, and citizen science. And in the marketplace area, we have collaborative issues collaborations among the task areas among each other, and also collaborative issues to the outside world. We have here, if you want to go edit, in principle, a document, you go here to this link here, edit page on GitLab, and then you can actually edit your document and commit your changes, and then this is propagated back to the intranet. And also you have here a convenient method to search for keywords, full text, and you can find the content you are looking for in the Punch internet. So here we have a list of collaborative tools which we provide already by Punch4NFDI. We have the gray tools here. They're actually not yet AAI compliant. So we have a public website where you can find information about Punch4NFDI and the mailing list. We have Indigo for managing conferences and meetings and slides. And in the end, we have also a cloud share, sync and share at DESI.de. I come later for that, to that, which is used by Punch for joint collaboration, for joint editing and managing of Office-like documents. And we have, as I mentioned already before, Storage for Punch, which is a prototype for federated storage infrastructure for Punch4NFDI. The upper services are currently all hosted by DESI. And then we have the next set of services. They are all already AAI compliant. We have Gitlab, and which Harry already talked about in detail. We have Mattermost. I come later to that, which is a chat tool where we can efficient and fast communication among Punch members. And we have the intranet I talked already about, and we have the Punch Science Data Platform where Harry talked about. We have Compute for Punch, where users can also authenticate and do authorization already via AAI. And the compute resources are currently provided by KIT, DESI, and FZ Jülich, and some more. And here, this is, as I mentioned, a federated prototype of a federated computing infrastructure for Punch4NFDI. And we have, as a central component, the Punch4NFDI AAI, which provides login to all these Punch services. And this is hosted by FZ Jülich and HIFIS. So if you want to go as a Helmholtz service, HIFIS. So here we have a view of how to log in to DESI Sync and Share, which is used by Punch for collaborative writing of Office-like documents. So you can log in here by your local user ID and password of DESI, but you can also log in via Keycloak. And Keycloak is a central single sign-on service. It is open source and it supports all standard protocols and is very scalable. So if you choose here to log in via Keycloak, you in the end get the screen where you can choose that you connect via Helmholtz AAI. And if you connect via Helmholtz AAI and you are group Punch, you are connected via the endpoint of the Punch AAI to the DESI Sync and Share services. Next slide. And here is how it looks in principle. So you have Office-like documents, and you can just edit them and store them and look at them and browse them as you would do with standard local Office documents. The only main difference is that you can share the documents among the community with the members you want to collaborate and share the documents with.
Kilian, can we speed up a little bit?
Yes.
Because we are, I think there might be questions or room for discussion.
So, and we have Mattermost for efficient communication. As I said, this is already for communication, okay, for fast communication. Next slide, please.
Yeah, okay, so just in time for ending, what I think is important to take away is here that we try as much as possible to integrate our collaborative tools into the all-over working on the science data platform, on the construction of the science data platform. And I think each other approach would squander a lot of intelligence and resources. And that's one of the things which are, to my mind, important to take away from this. And also that running a Gitlab for, let's say, a consortium provides more than just software management, which is original, of course, the origin. But we are, for instance, of course, willing to provide this kind of small addition to using Gitlab as a kind of wiki or Ersatzwiki, because it allows to follow you, follow all the changes you make to the intranet, and also you can do it collaborative. We, of course, are willing to provide these developments. These are just small web applications which do the trick of interacting with Gitlab, just for instance, and just as a reminder. Okay, with this, I think we should stop talking and leave at least one room for 1 or 2 questions.
Kari, Kilian, thank you very much for this great overview. We will end the stream and the recording